Hello all. So in this video we will continue with that feature engineering techniques of our loan eligibility prediction dataset. In our previous video, which is a part 1, we have covered some of the feature EDA techniques. Now we will proceed further. Okay, so this is our dataset. Okay, so so first of all, we have to handle the missing values. How we can handle the missing values is like you have to fill that either with the mean or mode. So we can identify the missing values by sum of. Okay. So gender, dependence, married, self-employed, loan amount term, credit history, and these values have NaN, which is not a number. This is NaN, which is not a number. So we're going to fill that now. So if you need to find unique values for each of your variable, you can just find it by df dot then gender dot unique of. So this will give male female NaN, like you can check for any other fields. Now I will check for loan amount on loan. Unique. Okay, so now we will replace that. Fill Na of df of gender dot mode of. In place equal to true. And so how many numbers, how many fields? 1, 4, 5, 6, 7. Okay. And for this is married one, married, dependence, and here we have self-employed. Self-employed and loan amount term, credit history. Loan amount term, those are all number variables and number features. So we cannot use this mode of for that. So we have to use mean or median for that. So gender, married, dependence, self-employed, loan amount. But for credit history, we can see credit history is something like that one we cannot. It will be ranging from 0 to 1. So or 0 or 1. So the most of the values has either 0 or 1. If you just check it here, df dot credit dot unique. See either 1, 0 or NaN. So instead of going for that average or something, so we will go for that mode here. Mode 0. But for this loan amount and loan amount term, that is for loan amount term is also, see loan amount term is like a total number of months or a period. which you're going to repay your amount. So we can find df dot term dot unique. Okay. Yeah, it's like multiples of months, right? So here also we cannot go by that mean. So here also we will go by the mode, which is a maximum frequent one, a frequently occurring value. So loan okay. Invalid syntax. Okay, here in place equal to true. Now we will replace our non-categorical feature, which is our loan amount. Here we have loan amount, right? So we have to use that loan amount. So mean, I'm using mean. Okay, now we will verify once again. Df dot is null the sum of 0. So we are good here. So df dot head of okay. So now it looks, I mean, we have removed all that. I mean, we have taken care of that missing values. Before we do that one-hot encoding, we can remove this loan ID, which is an identifier which does not have any impact, or which doesn't give any meaningful information to our data set. So we can just remove that loan ID. And we also have applicant income and co-applicant income, which means like both are incomes. Some cases it will be 0, some cases it will have a value. It's like if there are one or more applicants, and a husband and a wife together's income can be clubbed, and that will be considered by the bank. So here we will create one more field which is called as a total income, and we will sum applicant income plus co-applicant income. So df of applicant total income equal to applicant income. Okay, now this loan ID is not needed, so df dot drop off columns equal to loan ID, comma, since we have applicant income and co-applicant since we have already clubbed that 2 columns into 1 column, we don't need that, else it will have a correlation. Sorry, applicant income, co-applicant income, what is it, co-applicant income not found. Okay, df dot head of Okay, so now we have that total income, and that other one has been removed. Okay, now we can check the correlation now. Okay, correlation matrix is equal to df dot correlation of correlation features is equal to matrix dot index. Okay, now we have to plot heat map of df features dot correlation Okay, now we can mention a size plt dot figure of fixed size is equal to 15, 15. 15, 15. This is too heavy. 10, 10. Okay, so here actually if that so generally what we do is like if the value is above 0.85 or something 0.85, then we will drop that feature because it has a strong positive correlation. Similarly, if it is going in the negative way, it implies a negative correlation. So always we maintain a threshold, let's say 0.85. After that we will be dropping that features. So here we are good to go. And one more thing, like since we have couple of what can I say, couple of continuous features, so we need to check whether how they are distributed. So in case if you are going for linear regression, we don't need to check that. I mean, if in case if you are going for linear or linear models, then we have to check whether our continuous features are normally distributed. So how we can verify it? By using a box, by plotting a histogram, like df of, we have total amount dot hist of bins equal to 25. This is 1. And df of total amount sorry, total income. This is right skewed. Okay, so what we can do is we can add one more column, total log equal to, this is a log transformation. We are applying log transformation on top of our continuous feature so that it's get normally distributed. Total income. Then we will plot the same again. Now it is distributed normally. It is forming a bell curve, right? So that is what we say as a normal distribution. Okay. Now we have one more continuous variable. What is that? Total income, loan amount. Yeah, we will check for loan amount as well. test of bins equal to 25. Okay. Loan amount, this is I mean, I can say it's already normal, bit okay, but we will try to do some log transformation and see if this is getting improved much better. Okay. This is much more better. So this is good. So now we will drop off that that actual value. I mean the original continuous features. Else it will have a positive correlation. df dot drop off columns equal to loan amount total income in place equal to true. Okay. Loan amount log, total income log. Okay. Now we will take care of handling the categorical features. So how we will do? So how can we do that? So actually there are a lot of ways to do that. One is that one hot encoding, or you can go for label encoder. I mean there are a lot of ways to do that. So I will go for pd.get dummies of drop first. See, drop first in the sense like it will avoid the dummy variable trap. Good. So what is the shape? Okay, 14 rows. Loan amount term, credit history, total income log, male, married, document, okay, self-employed. Yeah, this looks fine. So these are all the feature engineering techniques that we have handled so far. We will wind up this video now, and we will continue splitting the data and creating some models in our next video. Okay, thank you all.